Okay, this is a lesson on Chapter 3, Section 5. We're doing some basic matrix operations. Be sure to go through and look at the examples in the book as well as the tutorial so that you can go back and reproduce the steps that we're doing today. All right, so the first thing you want to do is if you want to add or subtract matrices, they must have the same rows and columns in order to do that. If any one of the matrices, if one has a 4 by 4, in other words, 4 rows and 4 columns, or 2 by 2, you can only add or subtract one that has the same number of rows, and again, rows go across as columns as each other. They don't necessarily have to be a square matrix like this, but they have to have the same dimensions. So the general equation for this is that if it's in the same position, this is the first row and the first column, then you add it to the number in the same position of the other matrix. So A and E would be added together and they would end up in the same position, which is row 1, column 1, as they originally were, since we're adding. B and F happen to be in the same position, row 1, column 2, and that number would end up in the row 1, column 2. C would be added to G because they're both in row 2. This is row 1, row 2, column 1, column 2. Row 1, row 2, column 1, column 2. So they have to be in the same position. This is row 1, row 2, column 1, column 2. Okay? So then row 2, column 2 is D, and row 2, column 2 is H. So D and H would then be added together. Very similarly, if you're subtracting, you're going to do the same thing. A subtracting E. So it's A minus E, and they're in the same position they started. B minus F, C minus G, and D minus H. So that's pretty simple. All right, so let's do an example. I have a little bit of color coding here. So we want to add these two matrices. Yes, they can be added because they have the same number of rows as each other and the same number of columns as each other. So the 2 and the -3 are both in the same position. When you add 2 to -3, you get a -1. When you add 4 to 2, you get 6. 0 and 4 give you 4, and 1 and 0 give you 1. So let's look at this one. 4 minus 2 is 2. 6 minus 3 is 3. And again, we're going to put the answer in the same position as the elements that we were using. -2 minus a -4 is the same thing as -2 plus 4. So that's a 2. And then 2 minus 2 is 0. 1 minus a -3, which means 1 plus 3, so that gives you a 4. And a 5 minus 1 is 4. And that would be your final answer. Okay? All right, so let's look at the next one. There's something called scalar multiplication. It's the very easiest type of multiplication with matrices. And this multiplication means that you have a number. This could be positive or negative. It could be a fraction, a decimal. It doesn't matter. But you have a scalar number out here. And when you do that, you're going to multiply it by every single element in the matrix and put the result in the same position as the original element. Okay? So for example, you're going to multiply 4 times 3, and you're going to put that in the same position here. 4 times a -2 is going to be -8, and that's going to be in the same position as the element. Row 1, column 2. 4 times 0 is 0, and 4 times 3 is 12. 4 times 1 is 4, and 4 times 6 is 24. Same kind of thing. -3 times a -1 is a +3. -3 times 5 is -15. -3 times 4 is -12. And anything times 0 is 0. So scalar multiplication is pretty straightforward. You just remember to multiply every single element and put it in the same position as the first element. Again, each of these numbers are called an element. So now let's kind of put it together. All right, so if you have an equation, something like this, and look, all of a sudden there's some variables in here, but don't fret, you're going to be fine. So there's a scalar multiplication going on, there's some addition going on, and then there's a matrix over here. So the first thing you're going to do is, just like you do in PEMDAS, you're going to take care of this stuff in the parentheses. Well, we already know that the same element has to end up in the same way. So this particular element is 2x minus 1. That goes in the first position. Negative 3 plus 4 is a 1. 5 plus 3 is 8. And negative y and 5 go here. It looks kind of weird, but that's exactly what you're supposed to do. So now we've identified this. So there's a scalar out here. So we have to take this scalar and we have to multiply it by everything in the matrix and leave it in that position. So 2 times 2x minus 1 is 4x minus 2. 2 times 1 is 2, and we're going to put it in that same position. 2 times 8 is 16. And then 2 times negative y plus 5 is negative 2y plus 10. All right? Now that we perform the scalar multiplication, we have a matrix that's equal to another matrix. Well, anytime you have a matrix that's equal to another matrix, you can say that anything in this position is going to be equal to something in this position. This position is obviously equal to this. 2 is equal to 2. 16 is equal to 16. And this value is equal to that. So to solve it, you're going to rewrite the elements in equations. So we know that this is equal to this, so we're going to write that out. 4x minus 2 is equal to 10. And we can add 2 to both sides. 4x is equal to 12. So x is equal to 3. So you've solved one of the variables. Well, we have another variable here, so we need to solve that as well. Negative 2y plus 10 is equal to 14. Why? Because they're both in the same position. So subtract 10. Negative 2y is equal to 4. And y is equal to negative 2. So the solution, we're going to put it in coordinate form, in the form of xy is equal to 3, negative 2. So I encourage you to go to the book and do some of the practice problems following these steps. Again, just to review, when you're adding and subtracting matrices, they have to be the same number of rows as each other and the same number of columns as each other. So you could have a matrix, for example, that's 2, 1 plus 0, 4. That would be okay. They both have 2 rows and 1 column. So you would be allowed to do that. So this would be 2 and 5. So they don't have to be a square matrix like this. In other words, 2 by 2s. So you're adding them, and remember you're going to put the result in the same position as the original elements. When you're subtracting, you're going to put the result in the same position as the original elements. In other words, rows and columns in that position. Okay, and we did a couple of examples. When you scalar multiply, again, this can be a whole number or a fraction, positive, negative, it doesn't matter. You simply multiply it by every single one of the elements and then put the result in the same position. When you're solving a matrix equation, if there's variables in here, you simply use your PEMDAS and do what you're supposed to do first. Go ahead and put the whatever's in the parentheses, go ahead and take care of that first. Then do your scalar by everything. And then when you're done, you should have positions that are equal to each other. And whenever you get to that point, you can simply rewrite them in normal format the way you're used to doing. Good luck!